Hello. Okay, let me know. My voice is audible. Just put your answer in group chat. Okay, fine. Can you see my? Okay, okay, fine, fine. Okay, and what about screen? The screen that I have shared. Screen also visible, all of you. Just let me know. Okay, fine then. Okay, first of all, I welcome all of you in the third year new semester. In today's lecture, we will go through first of all the overall introduction of the digital communication, which is the next part of analog communication that we have studied in the last semester. So, if you compare the analog communication and digital communication, okay, so the only difference is between the information that we have to transmit. Okay, so in analog communication, the information that we deal in by using some modulation technique like amplitude modulation or frequency modulation. So in that case, the information was in continuous form. Okay, now in as a subject name is a digital communication, so obviously the information that we will transmit or we have to send over the distance, long distance, that information first of all we have to convert into the digital form. Okay, so in the first 4 unit we'll deal with how to convert analog information into digital information. Okay, fine. Now if you compare the modulation technique, digital communication and analog communication, so in both the cases the modulation techniques are same. The only three modulation techniques are there: amplitude, frequency, and phase modulation. Okay, but here, before going to study that modulation technique, uh, as I said earlier, we will discuss about how to convert analog information into digital information. Fine. Now, particular for this digital communication unit subject, there are 6 outcomes, and these 6 outcomes are based on total 6 units. Simple as that. So these are the statement. So in the first unit, you are going to study, and the overall statement it's framed like a course outcome. So these are the statements. Okay, I will share this PPT. Just go through this CO. These are the course outcomes after studying every unit. So that will be your final aim as a course outcome. Now let us go through the syllabus here. Before going to the syllabus, let us discuss here the overall exam pattern. So as we know, up to the second year, you had given online plus theory examination. So the overall distribution of 100 marks is like 50 and 50. 50 for online marks and 50 for the theory marks. Okay, but from the third year now, the overall examination pattern is like this: 30 plus 70. So the 30 marks is in same for in same, and remaining 70 marks for the end same. Okay, so for 30 marks examination you have to prepare for 3 units. Okay, means 30 marks examination, for the 30 marks examination you have to prepare 3 units. Okay, and for 70 obviously you have to prepare all 6 units. So this is the overall theory examination scheme. Okay, and the units that you have to study here. So in the first unit is a digital transmission of analog signal. Okay, so as I said, first of all we will deal with how to convert whatever the analog information that we will have, because we know the information is in different format, right? So whatever the information is there which is in analog format, that analog information we have to convert into digital format first. Okay, so in the first unit we will study in detail how to convert that analog information into digital information. Okay, so the concept of this one, analog to digital information conversion, so in the last semester in the analog communication last unit. Okay, so in that unit we studied sampling. Fine. So in this case, in first unit also we will start with sampling. Fine. So sampling means just to convert analog into discrete, not digital. Okay, that is a sampling. That is the first process, sampling analog to discrete. Okay, so after that, discrete information signal we will convert into digital information. So these three blocks, or we can say the process, we will study in unit number 1: analog to discrete. Okay, after that discrete to digital, and how to transmit that digital information means binary form. Okay, serial parallel conversion is there. Fine. So the topics that we will study here, means mainly you have to study sampling, quantizing, and encoding in unit number 1. That is the basic points that you have to understand. Okay, that is digital transmission of analog signal. Okay, if you have any query, just put your question in chat room or doubt session. Okay, let me check first of all. Okay, let me know, screen is okay for you, it is properly visible. Okay, okay, fine, fine. Okay, fine, don't worry, I will zoom it. Fine. Okay, now, as I said, in digital communication, in the first unit, digital transmission of analog signal, as the name suggests there, how to transmit analog information into digital form. That is a conversion. So these are the different, we can say the topics are there, but the overall conclusion, or we can say the concept that you have to study here: sampling, quantizing, and after that encoding. So these are the three methods that you have to study in detail. Okay, that is unit number 1. Okay, now let's see what about the unit number 2. That is the baseband digital transmission. So as a name here, it is given baseband digital transmission. So why the name it is given baseband? Because after converting that analog information into digital, digital means binary form 1 and zeros. Okay, so whatever the information that we will have in digital format 1 and 0, that signal is nothing but the baseband digital signal. Fine, so just remember. So that is the baseband digital transmission. Okay, so baseband digital signal means just a binary form, as we can say here, baseband digital signal. As we know, key in the analog communication, the information signal or baseband signal, we use the different names like message signal, information signal, baseband signal. Okay, but here in digital communication, baseband signal is nothing but in binary form 1 and zeros. Fine. So in unit number 2, the topics are multiplexing, multiplexer, and hierarchies. So multiplexing, already we know the concept of multiplexing. In analog communication, there was one type, frequency division multiplexing. Okay, so why the name it is given frequency division multiplexing? Because all the information, different information, if you want to transmit over the common channel, so that is the multiplexing. Okay, so okay, fine, but that frequency division multiplexing we use, or the name that we use, because the all the information signals are in continuous form, analog form. Fine. Similarly, when we will have a different binary information, okay, so in that case, that is digital multiplexing, and there are different types and hierarchies also based on the data rates. Okay, now that multiplexing here we called as a time division multiplexing. So remember, in analog communication, when we have to transmit a different analog information signal over the common channel, so that type of multiplexing is called as the frequency division multiplexing. And when we will have, means when we have to transmit a different binary information over the common channel, so in that case we have to use time division multiplexing, TDM, FDM, and TDM. So there are different types, and some numericals also based on particular topic. Okay, so that we will study in later. Just remember the topics and what the content that you have to understand or that you have to study. Okay, after that there are data formats. Okay, as we know, when we have to plot any analog signal, okay, so it has a proper shape. For example, sine of x. Okay, so sine of x, if you have to plot, so purely sinusoidal signal that we can plot. Okay, but if you have a binary data 1 and 0, so how do you plot here? Obviously we have to represent some voltage levels. So we have only binary data, means we have only 1 and zeros. So whatever the digital information, obviously it is 1 and zeros. So the representation of the binary data or a digital signal is nothing but what? Representing some voltage levels for bit 1 and bit 0. Just understand how to plot binary signal, baseband signal or digital signal. Okay, that means we have to represent some voltage level. Means, for example, if you want to draw 1 and 0, 2 bit. Okay, so for bit 1 we will represent 5 volt, and for bit 0 we will represent minus 5 volt or 0 volt, like that. Okay, so the representation of the binary data is nothing but what? Just representing some voltage levels for bit 1 and bit 0. I think it is okay for understanding the binary signal how to plot. Now, the next important point regarding the baseband digital signal is data format. Okay, even though whatever the data is there, one and zeros, when we will plot, it look like a simple square wave for bit one and bit zero. Obviously, it look like a simple square wave, but there are also different ways to plot a binary data, one and zeros. So there are, I think, almost 8 to 10 different formats are there, so that we can represent our data in one and zeros. So the representation of the binary information into different format called as a data format. Okay, so the data format we will study in time domain as well as the frequency domain. As we know, when we will plot a spectrum, or we can say, if you take the Fourier transform of the square wave. Okay, so obviously as a result we will get there is a sinc function. Fine, so that sinc functions of different data formats is nothing but the spectra. As you can see, the word is a spectra. Okay, so the data formats we will study in two domains: time domains, that is the data format, and the frequency domain called as the spectra. Synchronization. Okay, now the important thing is, in digital communication is synchronization. There should be a proper synchronization between the bits as well as between the symbols or between the frames. Okay, now as here we use two words, frame and group of bits or symbol. Okay, so frame and symbol both are the same, but to understand here, frame and symbol is nothing but when we will combine more than one bit. Okay, that is called as a frame, 2 bit, 3 bit, 4 bit. Okay, so it is a group of bits called as a frame or symbol. Try to understand. Okay, so when we will combine or when we will transmit a group of bits in the form of frame or symbol, or sometimes in a computer communication, means computer networking, we use that word as a packets. Okay, that is a group of bits. So there should be the proper synchronization between these frames or between the beats or between these symbols. So there are also different types like a bit synchronization, a symbol synchronization, and frame synchronization. Fine. Now the next part is a scrambler. Scrambler is nothing but what? To provide some security. Okay, so that is a different part to understand scrambler. Just remember, scrambler means when we have to transmit our information into secure format. So in that case, we use the scrambler. Fine. So this is all about the unit number 2. Now let's move to the unit number 3. Now here, the random signal and noise. It is a completely different unit if you compare with unit number 1 and unit number 2. Okay. So it is depends, means the overall points here we will discuss later based on the process. So which process? There are the random process. Okay, as a name here it is random signal and noise, but actually the name is, it is a random process. So to understand this random process, we should first of all we know the knowledge about the probability, as we have, as we already studied in 12th standard, the probability unit. Okay, so that type of concept here we have to revised to understand this random process. Okay, now all these parts we will discuss later. Just remember, random process means, we know that when we transmit any information or one point to another point, there are many chances to introduce the different types of noise. Okay, as a random signal. So based on that concept, what are the different points that we have to understand when we transmit digital signal and when noise is introduced in that case. Okay, so that point of view we will study this random signal and noise. This is unit number 3. Now after that, unit number 4. Students, here you have to understand, now it is unit number 4, but still I have not discussed about the modulation. Okay, what happens in analog communication? From unit number 1 itself we started their modulation, and that is a band pass modulation, amplitude modulation, frequency modulation. From unit number 1 itself means we started with their amplitude modulation. But here Now it is unit number 4, but still we are discussing about the baseband signal only. Are you getting my point here? Okay. Now here, unit number 4, the baseband receiver. As we know that for a different signals, we need a special type of receivers. Okay, so already in analog communication, we gone through a different types of receiver that we use to design for amplitude modulation, frequency modulation. Okay, but here our information it is in digital format. So before that one, what are the different parameters that we require to design a special type of receiver for if you're transmitting the information in digital format, one and zeros. Okay, so just I am just reading reading the some filters, or we can say the receiver that we used in digital communication. That is optimum filter. We will start with the optimum filter. After that, match filter, and after that there is a simple coherent detection filter, or we can say the correlation receiver. Okay, so here optimum filter, match filter, and error probability, these are the very important points that we will discuss obviously later, but just remember what you have to you have to study under unit number 4. If you have any query, just put your query in that chat box. Okay, fine. Okay, this is all about unit number 4, that is baseband receiver. Now, from unit number in 5, actually we will start the modulation technique, that is digital bandpass modulation technique. So again here, there are not different modulation techniques. Whatever the modulation techniques that already we have studied in analog communication, because the same parameters are there, amplitude, frequency, and phase. Okay, but only the difference is here, the information that we have in digital format now. Okay, therefore the names are changed here, like you can see here sk, that is shift keying. Okay, so phase shift keying, frequency shift keying, and amplitude shift keying. So these are the basic modulation technique that you have to study: amplitude shift keying, phase shift keying, and frequency shift keying. Okay, now the why the name it is given is shift keying. Okay, because as we know the simple definition of the modulation. Okay, what is modulation actually? Means some part of the carrier signal are changes according to the baseband signal. Okay, now we have the baseband signal in digital format 1 and 0. Okay, so obviously the information is 1 0, like 1. Let us consider if we have a information 101 is 3 bit 101. Okay, now we can see here, means we can understand here 1 to 0 and 0 to 1, that is the shifting. 1 to 0 and 0 to 1. Okay, so whenever there is a shifting, according to that the parameter of the carrier signal are changes. And keep in mind here, the carrier signal that here we are using, it is in pure analog format, not a digital. Okay, in analog communication, both the information, analog means message information signal and carrier signal, both are in analog format. Whereas in digital modulation technique, the modulating signal, or we can say the baseband signal, it is in digital format 1 and zeros, whereas the carrier also here analog format that we already studied in analog communication. Okay, so it is very important. Okay, carrier signal it is in analog format. Fine. So here, as I said, one example, if we have a data 101. Okay, now first bit is 1, second bit is 0, and third bit is 1. So if you are moving from one first bit to second bit, it is shifting 1 to 0. Okay, so whenever there is a shifting point, okay, at that point the parameter of the carrier signal are changes. So therefore the name it is given shift keying. Okay, keying means switching. Okay, so amplitude shift keying, phase shift keying, and frequency shift keying, these are the basic modulation technique that we have to study. Okay, after that some special cases we will study, like you can see here, there is a binary phase shift keying here, binary phase shift keying, and quadrature phase shift keying. Quadrature means there are combination of two PSK, that we will study later, don't worry, but just remember the basic modulation technique that you have to study here: amplitude, frequency, and phase, and the name is here shift keying. Okay, now you can see here, that is Mri Psk, Mri QAM. Okay, so Mri Psk means when we are combining, means As I said here, the data is 101, so 120 and 021. At that point, the parameter of the carrier signals are varying. But when we are combining the data and transmitting the information, means let us consider if we have a data 1 1 and 0 0. Okay, I'm repeating again. If we have the information signal like this 1 1 and 0 0. Okay, so let us consider if you are combining two bits. Okay, so what is the first one here? That is 1 1. It is the first symbol, and the next bits are 0 0. So there are two symbols. Okay, so when we are transmitting some information in the group of bits, such type of modulation is called as the Mri signaling. Okay, so just remember here. Now this is all about the unit number 5. After that, in unit number 6, that is spread spectrum modulation. So after studying the basic modulation technique, digital modulation, passband modulation technique, here the methods that we use to secure our information in digital communication, that is spread spectrum modulation. Okay, so in that case, we have to study two methods: direct sequence spread spectrum and frequency hopping spread spectrum techniques. Here you can see direct sequence spread spectrum and frequency hop spread spectrum techniques. Okay, so these are these some security at the when we have to provide some security to our information signal. So in that case, we have to use that spread spectrum techniques. Okay, these techniques generally I can give some example. In mobile communication, we can means we use this spread spectrum techniques. Okay, in cellular mobile communication. Okay, so this is all about the spread spectrum modulation technique. Okay, so this is all about the syllabus of digital communication. And as we know, we in analog communication also we started with the basic block diagram of the analog communication. So here also we will start with the basic block diagram of the digital communication. Okay, now it is very easy to remember that block diagram. Okay, before going to show that overall digital block diagram, let me tell you, just remember these 6 units, okay, as a block of the digital communication system. That's it. Okay, there is a very simple method to remember how to draw the digital communication block diagram. Okay, there are the 6 blocks, means 6 units in digital communication block diagram. This is all about the syllabus. Now here there are some textbooks and reference book. I will provide some soft copy also, PDF copy, don't worry. Now in shortly we will discuss over the practical session, means practical examination scheme. Okay, now in second year, for every subject, means whatever the subject I had there some practical or examination. Okay, you appeared there different, means separately or individually you appeared for the practical examination. But in third year, as you can see the name head here, signal processing and communication lab, that is a 50 marks. Okay, now DSP and DC is a combined lab, means in the examination we have to prepare for DC practical as well as for the DSP practical. Means for both the practicals की जो एग्जाम होगी वो सेम होगी, एक ही एग्जाम. देयर इज अ नो डिफरेंट एग्जामिनेशन, नॉट अ सेपरेट एग्जामिनेशन फॉर DSP subject and DC subject. Practical examination I'm talking about. Okay, whatever the examination is, there is a combined examination of DSP plus DC. Okay, but don't worry, whatever the cheat that you will pick, based on that you have to perform only one experiment. You have to perform either DC or DSP. Okay, so this is all about the practical examination pattern. Okay, now let's see what are the practicals under digital communication head. So there are two groups, group A, as you can see here, group A and group B. So in group A, the practicals that you have to perform all are hardware based practicals. Okay, and in group B, uh, which are based on the MATLAB software. As already we familiar with the MATLAB, already some AM and FM practical we did in analog communications. In same way, we will write some program for this PCM or QAM, like that. So group A hardware practicals and group B are software based practical, that is MATLAB. Fine. So this is all about the syllabus now. Okay, now let's see. Okay, let me know up to this one it is okay, or if you have any problem, or shall I continue? Okay, fine, fine. Okay, now let's see here. The basic question that arise here: how do we compare analog communication and digital communication, or simply which one is better, analog or digital? Okay, now here you can see this is the pure sinusoidal signal. Okay, and after converting that analog information into digital information, obviously it look like a square wave, but this part is nothing but bit 1 and here it is bit 0. So how we can see it is bit 1? Because here there is a some, there will be a some voltage level, something around, let us say, the 5 volt. So it's a plus 5 volt as a bit 1, and the 0 volt we can say here it is a bit 0. So 101010 is like that. Okay, so this is a digital signal. Okay, now why means, or simply the means how digital communication is better than the analog communication. Okay, as we know, key analog signals for the long distance communication which suffer from many losses, and the introduction of the distortion is also is very high, means chances of is very high to introduce the noises. Okay, and it is a information in band pass analog modulation. It is in continuous formats. Okay, so at the receiver side, when we will detect the signal, so that shape of the signal matters. Okay, it's very very important. Listen carefully. When we will detect analog signal, means like in amplitude modulation or frequency modulation, the shape of the signal matters. Means as we transmitted this analog signal from the transmitter side, the same shape of the signal we should receive at the receiver side. Okay, if the shape is not proper, obviously some data will loss. I'm talking about in analog case. Okay, but not in the digital communication, because in digital communication we will detect this digital signal. Just we have to detect what is the voltage level for bit 1 and bit 0, even though if there is some distortion at this level or at this level. But in that case also, just we have to know, means we will get some information that if such part is there, means there is a bit 1, and if such part is there, it's bit 0. Simple. So shape, the conclusion of this topic is the shape of the digital baseband signal, it doesn't matter in digital communication, whereas in analog communication the shape of the message signal matters. Okay, that is the basic thing that you have to understand here. Okay, now let us see what happens in analog communication. Many losses, distortion, interference, or other losses, including the security breach. Security is also is very important part. Okay, but in digital communication we can provide in proper way the proper security. Okay, that means the digital signal allows the communication to be more clear and accurate without any losses. Okay, so the conclusion of this one is that signal to noise ratio, that is a very important point already we discussed. Okay, so signal to noise ratio of the digital signal is very high as compared to analog signal. Okay, as we know, signal to noise ratio is nothing but what? If the distortion is very less, we will get the more signal to noise ratio, and if the distortion is very more, obviously the value of the signal to noise ratio we will get a very low value or less value. So from that value or from that parameter we can say analog, or sorry, digital signal is, or digital communication is better than the analog communication. So already I have discussed in the while discussing the syllabus, this pattern, why digital. Okay, now let's see what are the advantages of the digital transmission. Okay, now the regeneration. The regeneration means between transmitter and receiver. If you remember the basic analog block diagram. Okay, so after transmitting the signal, okay, so between transmitter and receiver there is a channel. Okay, so for the long distance communication there are regenerators. Okay, but in digital communication, obviously in digital communication also there are repeaters. Okay, but here in digital communication there are regenerative repeaters. because the data it is in digital format. So therefore, the between transmitter and receiver, okay, in the long distance communication, we are going to use the regenerative repeaters. Instead of using repeaters we use in analog. If the information is analog format, so in that case we use the repeaters. But here, when we have to transmit our information in digital format, so between transmitter and receiver, okay, so in that case we have to use regenerative repeaters. Okay, so noise limit is very good as compared to the analog communication. The cost also reduces because the whatever the technology is there, digital technology, okay, and the designing of the transmitter receiver part. So as a result, the cost is very much reduced because the digital circuit is not that complicated as compared to analog one. Okay, so as a cost very much reduced in digital communication. Multiplexing is very easy because after multiplexing we can transmit the more data there. That is a very important part of this digital communication. Security also is very good, encryption and decryption that we use in digital communication. So there are some advantages of the digital communication. Now let's see some disadvantages of the digital transmission. Not that much the disadvantage as compared to the analog communication, but let's see. The compatibility. It is incompatible with the older version of the analog transmitter system. Obviously, the data is in digital format. So if you are using the old version of the analog transmitter, so obviously it won't work. After that, it requires the more bandwidth. That is the only disadvantage of the digital transmission. As we know, as a communication engineer, we should always try to minimize the signal bandwidth. Okay, but in digital communication, signal bandwidth increases, but the data transmission rate also increases. That remember. So that is the only disadvantage. Not that up to means both बड़ा भी disadvantage नहीं है, but it's okay, fine. Now let's see what are the digital system. Already most of the gadgets that we use, that we are using in day-to-day life, are digital gadgets. Okay, okay, these are some examples that we use the digital communication there, where we use the digital communication like data transmission, voice transmission, video, music, email, web pages, computer networking. Okay, in communication system today, radio, TV broadcasting, a set-top box, all these means we are using digital communication. There is a PSTN, this public switch telephone network, cellular phones, computer network, satellite system. Means in all the major communication system nowadays we are using a digital communication. Okay, now as we discussed in analog communication in while studying that bandpass modulation technique, so we have to focus three parameters. Okay, that is bandwidth, power, and the last one is overall the information. But the important two parameters are here, bandwidth and power. Okay, but here in digital communication, the important parameters means after generating a digital signal, so what should be the parameter that we can analyze? Okay, so maximize the transmission rate, that is the unit is R. You can use simple capital R or small r. Okay, be familiar with this unit, kbps, mbps, gbps. Okay, that is the transmission rate, means how many number of bits that we are transmitting per second. That is the transmission rate. Okay, and we know it is 1 mbps, 2 mbps, 3 mbps. So as we can say, it is 1 to 5 mbps, so data speed is increases. Okay, so that is not, then you can relate here the maximize the transmission rate. Means if you are increasing the transmission rate, obviously the data transmission rate is increases. Maximize system utilization, that is you. Means how do you means if you are maximize the system utilization, as a result the transmission rate increases. Simple. Now to minimize is very important, to minimize the bit error rate. Okay, now to minimize the bit error rate means what? For example, let us consider I have the data 101. Okay, from the transmitter side I have to transmit 101. Fine. And for example, at the receiver side, due to distortion, if I received 100, okay, what was our data? 101, and at the receiver side, if you received 100, okay, so one third bit is differ because at the transmitter side we have data 101, but at the receiver side we received 100. So one bit is different that we received. Okay, so what is the bit error probability here? out of 3 bit we received 1 bit wrong. Okay, so that is the error probability that we can calculate. So that is bit error probability, or we can say the bit error rate. Means whatever the number of bits that we are transmitting, if you are transmitting 10 bits, so exactly 10 bits that we can receive. Okay, that is the bit error rate. Obviously that is a common thing to minimize the system bandwidth or signal bandwidth. To minimize the system complexity, means whatever the design part is there regarding transmitter and receiver, that complexity we have to reduce there, and to minimize the required power level, that is AB by N naught. Okay, now here this ratio AB and N naught. EB means that is energy of the bit. Okay, EB means it is energy of the bit, and divided by N already we discussed in white noise, that is N. Okay, so this is all about the parameters that we will discuss. Okay, but here you have to remember this first parameter, that is the bit rate or transmission rate. Okay, after that the second parameter, this one, because in the first unit after converting analog signal into digital format 1 and 0, so we have to analyze that baseband signal with the help of this parameter, bit transmission rate and the bandwidth. Okay, so these two parameters are very very important while studying unit number 1. Means after converting any analog information into digital information. Okay, so just remember transmission rate, obviously it is in bits per second, that is the unit. It could be kilo bits per unit, or megabits per unit, or gigabits, kbps, mbps, or gbps, like that. So just remember total number of bits are generating per second. Okay, means after converting any analog information into digital format. Okay, so how many number of bits are generating, means how many number of bits that are representing that analog information, that is nothing but the transmission rate and the bandwidth. So if you are dividing by 2 here, r, if you are, I'm like writing like this, r divided by 2. So r divided by 2 is nothing but what, is equal to bandwidth of that signal. It's simple. The bandwidth is nothing but what, r divided by 2, that is bandwidth of the digital signal. Okay, now let's see the basic block diagram. Fine, it looks like a very big block diagram, but don't worry, it is very easy to remember. Okay, as I said, just remember the 6 unit name. That 6 unit name is are nothing but your block diagram. Okay, now in the first part you can see here it is a format. Now I think it is clear. Now the first block is format. Format means whatever the information we will have, for example it is in image format, or audio format, video format, whatever is there. Okay, so that format we have to convert into the one common format. Okay, already we know that is the transducer that we use to convert that format. Okay, and after converting that format, okay, in the common format, that common format we have to convert into the again digital format. Okay, that is the source encoding. Okay, now the combination of these two blocks, formation, format and source encoding, is nothing but your first unit, that is source coding. Okay, and you can see here some blocks, there are white box. Okay, and some box are containing some uh, lines there. Okay, black lines. Okay, that means these are the optional part, but in professionally when we transmit digital information by using any bandpass modulation technique, these blocks are required. But basic block diagram, if you want to draw, so the format, pulse code modulator, bandpass modulator, and transmitter, this is the basic block diagram. Okay, these are the optional, but not optional, but it is very very important. Okay, now let us see one by one. Format, as I said, different information format. Now next block is source encoding. Okay, now in the second semester you have, means you will study in detail this source encoding. Okay, but in this digital communication, in under that source encoding, you have to study the different methods to convert analog information into digital information. Okay, now in analog communication, the last unit, in the last unit and obviously the last part was their PCM, pulse code modulation. Okay, so the pulse code modulation, after that delta modulation, after that adaptive delta modulation, okay, and differential pulse code modulation. So these are the methods to convert analog information into digital. That is nothing but the source encoding. Now, as I said, these are the different methods to convert analog information to digital. And then what is the difference? Because in all the process, means all the format, the process is same, analog to digital. So what does it mean? The meaning of this one is, when we will convert any analog information into digital, so whatever the transmission rate that we will get their number of bits per second. Okay, so that we have to reduce there. Okay, so as we are reducing there, means as we are reducing the number of bits here, so as a result the signal bandwidth get reduced. Okay, the same concept that we have studied in amplitude modulation. Like in amplitude modulation, we started with the double sideband full carrier, and the last type was the single sideband suppressed carrier. Okay, so in double sideband suppressed carrier, the bandwidth we got there 2 FM. Okay, just remember, just recall. And in single sideband suppressed carrier, the bandwidth was there FM only. Okay, so we reduce the 2 FM bandwidth to FM. Similarly, in source encoding method, we will reduce the signal bandwidth. Okay, so how do you reduce from PCM to delta modulation, adaptive delta modulation? So these are the three methods that we have to study in detail. Okay, so while studying these methods, delta modulation, adaptive delta modulation, or differential pulse modulation, we have to analyze two parameters: the transmission rate. Bit transmission rate means how many number of bits are generating in 1 second, and second part is the bandwidth of that signal, bandwidth of PCM, bandwidth of DM delta modulation, or bandwidth of adaptive delta modulation, like that. So just remember, in the source encoding, or we simply just remember here, so the function of the source encoding nothing but to reduce the signal bandwidth. Just remember, encryption is the security part. This part you will study in the next semester subject, information theory and coding. No need to means in the digital communication syllabus there is means sorry, no need to study this encryption. Just we will study how to convert analog to digital conversion easier. After that, the channel encoding. That is a very important block. Now, what happens in channel encoder? As we can, as we know that in source encoder, function is reducing the signal bandwidth, whereas the channel encoder, source and channel. Okay, so after converting uh, any analog information into digital information, so obviously we will have the binary data 1 and 0s. Okay, so during the transmission there may be a chances to alter the data, like from 1 to 0 or 0 to 1. Okay, so in that case we have to reduce that bit error probability. Means whatever the bit that we are transmitted, for example, if you transmit bit 1, we should get bit 1. If you transmit bit 0, we should get bit 0. Okay, but due to distortion, if the data is changes like 1 to 0 or 0 to 1, so in that case, along with the information data, for example, we have the information data 101. Okay, so along with this 101, we will add some extra bits. Just listen carefully. What is the meaning of channel encoding? Okay, I'm repeating again. If you have to transmit the information 101, okay, this is the actual information in binary format 101. Okay, and if due to some distortion, okay, the data may change, fine. So along with this 101, whatever the extra bits that we will add, okay, so that extra bits are named as redundant bits. Okay, so that redundant bits we use to correct our data. Okay, so that process is called as the channel encoding. Okay, so just remember, the function of the channel encoding is to correct the data bits. That is called the channel encoding. Okay, so don't get confused between source encoding and channel encoding. I'm repeating again. Source, the function of the source encoding to reduce the signal bandwidth. Which signal bandwidth? Digital signal bandwidth. Okay, baseband digital signal bandwidth. I'm not talking about any modulation here. Okay, so remember. And channel encoding means what? To add extra bits called as redundant bits for correcting the data bits. So that is the function of channel encoding. Now, after converting analog to digital and doing some encryption and encoding part, the next part is multiplexing. Obviously, single signal we cannot means we will not transmit. Okay, obviously we will have different type of information. Okay, message information in digital format. So if you want to transmit different information over the common channel, so obviously here we will use multiplexing, that's multiplexer. Okay, so here we will use time division multiplexing. So in the second unit we will study in detail time division multiplexing. Okay, after that the pulse modulator. Pulse modulator already we have studied, that is pulse code modulation like that. Okay, pulse digital delta modulation or differential pulse code modulation like that. Okay, after that a band pass modulator. So this is the part where we introduce one of the modulation technique, band pass modulation. Either it could be amplitude modulation, frequency modulation, or phase modulation. Okay, after that this is a security part, means after we will have the band pass modulated signal. Okay, and keep in mind the band pass digital modulated signal is an analog signal, not a digital. Okay, because carrier is in analog format and information obviously in digital format. Okay, so it is a combination of digital signal plus analog signal. Okay, but after converting into band pass signal, it is a digital signal, means amplitude shift keying, phase shift keying, and frequency shift keying. These are the analog signal, not digital signal. Keep in mind, this is very, very important. Now here frequency spread spectrum, multiple access. Okay, so as we know, one of the telephone method, sorry, in cellular network we use port division multiple access. So that is one of the type of this multiple access technique. Okay, so this is the part of security. Okay, in the final year you will study in detail this multiple access technique, but in third year level we will study only this spread spectrum technique. Okay, so this is all about the basic block diagram, in nothing but your 6 units that we have to study. Simple, fine. And this is the exact reverse process that will happen at the receiver side. Okay, multiple access, it is a demultiple access, frequency despreading, demodulation, detection. After that demultiplexing, channel decoder. Here we are use encoding. So obviously at the receiver side we have to use the word as a decoding. If there is an encryption like a scrambler, I'm talking about encryption means scrambler here. So it is a decryption and source decoding and final format, whatever the information that we have at the transmitter side. So this is the basic block diagram of digital communication system. Okay, now in between this one there should be a proper synchronization. So here you can see one block is there, synchronization. So in unit number second we will study in detail what are the different types of synchronization. If you are transmitting bit by bit, so it is a bit synchronization. If you are transmitting in the form of group of bits as a frame, so it is a frame synchronization. Okay, so this is all about the basic block diagram of the digital communication system. Okay. At the end of the lecture, I will share these PPTs of the today's lecture. Fine. So this is all about the in today's lecture that we gone through the digital communication. Okay, how it is different from the analog communication and what are the advantages. Okay. After that, what are the topics that you have to study under this digital communication system. Okay. Now, fine. If you have any queries, you can share your query with in the group chat. Is it okay? Let me know. Or anyone can reply. Okay, 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 fine. Okay, I will share these PPTs. Just go through that PPTs. Okay, and if you have any doubt, you can put your question in WhatsApp group. Okay. Okay, 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 fine, fine. Okay, so here we will end this lecture. Fine. Okay, thank you. हॅलो 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 प्रकाश माईकचं काय रे
खाली झालं माहिती
नाही साऊंड मध्ये
अरे होणार नाही आता
ते बघ की साऊंड मध्ये
हॅलो एम आय ऑडिबल तुषार
तिथे बघ टेस्ट करू का अरे नो लॉंगर व्हॅलिड
सर ना ऑडिबल म्हणते
हॅलो तुषार आवाज येतो का रे हॅलो हॅलो येतोय म्हणतो आवाज येतोय का आता तुषार चॅट बॉक्स मध्ये लिहून सांग मला की आवाज येतोय की नाही येत सर नाव ऑडिओबल ओके 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 ठीक आहे ओके फाईन आता मी ना स्क्रीन शेअर करतो ते दिसते का मला सांगशील ओके चॅट बॉक्स मध्येच लिहून पाठव मला ओके हॅलो तुषार ओके फाईन दिसतं का ठीक आहे तुषार ओके वी विल मीट ॲट 2:30 अरे ब्लँक येते म्हणते स्क्रीन आता येते का आता दिसते स्क्रीन तुषार माझा आवाज क्लिअर येतोय ना ओके व्हॉट अबाउट स्क्रीन नाव ब्लँक ओके जस्ट वेट आता दिसते काय अजून ब्लँकच दिसते का तुषार स्क्रीन ओके फक्त 5 सेकंदासाठी दिसते म्हणते मग ब्लँक होते एक काम कर तुझं मोबाईलचं मला स्क्रीनशॉट मेल कर बरं नाही तर व्हॉट्सअपवर टाक जे प्रॉब्लेम येतो ना, ब्लँक स्क्रीन दिसते ना, त्याचा एक फोटो काढ, स्क्रीनशॉट घे आणि मला व्हॉट्सअप कर. ओके ओके. कोण गेलं रे? RFP आलंय. ओके ओके. ते हे बघ असं दिसतंय. हे बघ.
हा त्या ग्रुपवरला कुठल्या तो अपग्रेड
काय करू यार? असं काय करायचं आता?
ते पाठवून त्या ग्रुपवर. तोपर्यंत दुपारपर्यंत ते होईल प्रॉब्लेम, नाहीतर मग तुझ्यावर नाही.
ओके. हॅलो तुषार, व्हॉट अबाउट नाव? आता दिसते स्क्रीन? चेक कर किती वेळपर्यंत दिसतंय. याचं पण स्क्रीनशॉट पाठवशील ना मला व्हॉट्सअपवर, जे स्क्रीन दिसते तसं. दिसत. पहिलं ऍप्लिकेशन घेतलं ते तू हे घे म्हणला ना मला, ते पहिलं घेतलं मी. हो पण त्याच्याने दिसायला लागलं मी. दिसतं की हे बघ. बघा ते पहिलं घेतलं. ओके तुषार, आता काही प्रॉब्लेम नाही आहे ना स्क्रीनचा? ठीक आहे, चालेल चालेल. ठीक आहे, मग मी लेक्चरला भेटू आपण 2:30 वाजता. ओके, थँक्यू.
त्याला सांगितलं होतं जॉईन म्हणून.
त्याला आता काय करू, लॉग आउट करू का?
नाही, क्विट म्हणायचं.
कुठं आहे ते?
एक्झिट नाही करायचं.